The project that I will present you, it's called PETeR. It comes from Proyecto Educativo con Telescopios Robóticos. So you know that we astronomers have a great creativity inventing names with capital letters of strange or not so strange phrases. So before I present you the project, I would like to also have the idea of why a research center like the IAC is involved in things like this, like educational projects. So one of the challenges that I think everyone here has to face is how to get students, especially girls, but also boys, interested in STEM. And I say especially girls because we know that from the numbers that girls select, so girls do not select STEM studies or STEM careers as often as boys does, or boys do, sorry. So if we are going a step further, and we also want to encourage students to acquire STEM skills, and for some of them to develop future careers in those fields, the challenge is even greater. So what can we do to try to face that challenge? If we go to the studies on why students don't have a great interest in STEM studies, and for example, this study was carried out on more than 2,500 Spanish secondary school students, and it was about their scientific vocations. This study showed that the students attribute their lack of interest in STEM to three main reasons: the way these subjects are taught in schools, their complexity, or the idea they have that they are very complex things, and to the apparent lack of enough attractive professional opportunities. So the challenge is not only to engage the students, but also to engage you, not you because you are here during this intense course in the summer, but the teachers in general, and also the families or the society in general. And why? So I'm pretty sure that you know very well, and in case you have doubts, Rosa commented this the first day several times, and today I will repeat this, that you, the teachers, have an essential role in the perception of students about STEM, about science, about technology, mathematics, and so on. Because normally it's you who introduce them to these topics for the first time. And we also have the families, and they can also play an influential role in supporting or discouraging the STEM vocations of their kids. For example, probably and unfortunately, some of us probably have listened to a mother or a father saying, "Are you going to study that? This is not going to be this is not going to give you a real future or real opportunities in your life." Okay, when they are talking about mathematics or science or things like that. So we need to work on these three target audiences, and how can we try to engage these three target audience. So we have astronomy, and Fraser already mentioned this, that astronomy is the perfect engine, the perfect hook to arouse curiosity and interest in STEM subjects, both in young people and also in adults. But however, teachers, so many of you often tell us that it's sometimes hard to include astronomical topics in the curriculum of formal schooling. Fraser already commented that depending on the level that you are teaching and the subjects you are teaching, sometimes you find it really hard to include astronomical topics in your teaching practices. And also, you have also told us that frequently you lack for the adequate resources and training to introduce astronomical topics to your students in an attractive way. So this is why all of us are here. And at the outreach department of the IAC, where I work, we try to meet this challenge from different approaches. And one of them, the one in which I'm more involved, is that of educational projects, which include the three aspects here. First, we work on initiatives that engage students with interesting and motivating real scientific experiences, so they can experience real science, and also that involve you, the teachers, as key players. And for this, we provide resources and tools as the ones we are going to show you during this course. And we also provide training and support for you to use those tools and resources that could help you to develop a more appealing and stimulating STEM education. And we also want to contribute to changing an important thing, that is social stereotypes about scientists and science itself. And for this, we include, when possible, we include activities that allows interaction with IAC researchers, women and men. So the students and the society in general can have a more accurate idea of what is a researcher, what is an engineer, and that we are not all crazy people with a white coat on a lab. Okay, so yesterday we saw that due to the excellent astronomical quality of the sky over the Canary Islands, they house two of the best observatories in the world, the Teide Observatory on the island of Tenerife and the Roque de los Muchachos Observatory on the island of La Palma, which together have more than 50, we are now more nearly 52, I think, telescopes and experiments operated by institutions from over 20 different countries around the world. So these institutions and the IAC signed cooperation agreements under which Spain provides the site and its maintenance, and in return, the owner institutions give Spain a package that includes a certain percentage of observing time with its telescope. And this is very important for this project because in 2004, a new guy arrived at the Roque de los Muchachos Observatory. It was the Liverpool Telescope. It was the first of the 2-meter fully autonomous robotic telescopes, and one of the largest, and it is still one of the largest and more advanced telescopes even today. So the Liverpool Telescope is owned and operated by the Astrophysics Research Institute of the Liverpool Johns Moore University, and they decided to devote 5% of the observing time with this telescope to astronomy education and outreach in the UK and now in Ireland. So for that, they created the National Schools Observatory, and following their path, the IAC also made a major commitment to science education in Spain, setting aside for educational projects another 5% of the total time with this telescope. So for us, for Spain, it means that 25%, a quarter of the Spanish time of this telescope is devoted to educational projects in Spain. Here it is. So, so this is how this project PETeR was born. So PETeR is an online lab that dedicates some observing time with professional robotic telescopes to educational activities and research projects aimed at the students. The age of the students is from more or less 6 to 18. And as I said before, its name stands for Educational Project with Robotic Telescopes, in Spanish, Proyecto Educativo con Telescopios Robóticos. And our users consist of more than 280 primary, secondary, and vocational training schools in Spain, over 20 non-formal schools like science clubs and camps, and also after school centers, and about 20 amateur astronomical associations. We work with amateur astronomer associations because they also do activities with students and with young people. So our collaboration is just to have them also as collaborators or tutors in the project. So the project is also open to schools from other countries which are developing collaborations with Spanish schools. And I will come back to this later to let you know how you can request collaborate with Spanish schools. So we are not we only had a couple of collaborations in the past, like I think less than 10. But for the next year, as we are going to have, at the moment it's only me, I'm the coordinator of the project and the person who does anything at the moment. But we are lucky because another contract is going to be filled out for working on PETeR for the next school year. So we are going to be two people working on PETeR, and we are going to be able to have more schools to attend or to offer support to more schools. And we are going to also to try to have more collaborations among schools in other countries. So this is, if you are interested in the project, this is a very good moment to start working with us. So the main goals of PETeR are to engage students in science through their active participation in real research projects, while contributing to the diffusion of astronomy and astrophysics, also to stimulate STEM interest and vocations among students, and to train teachers on astronomy and on inquiry-based learning methods. The things that we are doing this week. And why robotic telescopes? So Fraser did a very good information, good introduction to this topic, and give a lot of information on why it's so interesting to use robotic telescopes for education. And I'm going to just mention 3 of the things he already mentioned. That the first one is that they can be used as online labs, and they are very convenient, a very convenient tool for bringing science to non-professional users because these 3 reasons. They operate in an autonomous way, so we don't need to be at the telescope, or we don't need to be, for most of them, for almost all the ones that I'm going to mention, we don't need to operate the telescope even remotely. They know, they have a very intelligent software that knows what to do in every moment. We just request the observations we want, and the software at the telescope decide which observation is the best one to do it at each moment. They are also accessible to anyone with an internet connection, and each night the telescopes can be used by multiple observers all around the world. For example, in the normal, or in the old way to do astronomy, we had to go to the telescope, to the observatory, to read the observatory during the morning, for example, or early on the afternoon, go to the telescope, prepare everything for the observations that night, go and have some food, and come back to the telescope to observe during all the night or half a night, and then you go to sleep in the morning. So only 1 or 2 different observers could use the telescope each night. With the robotic telescopes, many tens or thousands of observers can obtain, or more sometimes, depending on the time used for each observation, could use the telescope during one night. So it's a collective way of using those very important, very useful tools. So this project, PETeR, started in 2005 following the installation of the Liverpool Telescope at the Roque de los Muchachos Observatory, which I already mentioned is the largest fully autonomous robotic telescopes in the world today, or one of the largest with the Fox telescopes. So the robots that the Spanish schools and the other users I mentioned can use for studying the universe are the following ones. The largest is this one, the Liverpool Telescope, installed in La Palma at the Roque de los Muchachos Observatory, and it works in Q mode, as Fraser already mentioned. So that means that you request your observations. Those observations are added to a list of requests, and then depending on the priority of the observations, on the weather conditions, and on the conditions for observations that you have set the telescope that you want to have, then the software decides which observation is going to do at each moment. And in PETeR, we have around 40 hours of observing time with the Liverpool Telescope each semester. So in total, we have like 80 hours a year for observations in the Liverpool Telescope. Other telescopes that have been added lately to the project are those belonging to Las Cumbres Observatory, which has, I think now there are 22 telescopes of different sizes all around the globe, and 2 of them of 40 centimeters are located at the Teide Observatory in Tenerife, and we are going to also have 2 more, I think, of 60 or 1 meter. I'm not sure about the final size. That they already have the domes at the Observatory, and probably they are going to be full operating next year. So in 2018, Las Cumbres Observatory launched a call for educational partners to open its 40 centimeter telescopes to educational projects around the world. So we applied, and PETeR was selected one of the educational partners. And since then, we have been renewing our partner status, allowing PETeR users to make their observations with the robotic telescopes located at Teide Observatory and also at 5 other observatories around the world, both in the northern and southern hemisphere. So you can access telescope here in Tenerife, also in the US, in Texas, in Hawaii, in Australia, in South Africa, and in Chile. And among many of other advantages, the access to the LCO telescopes allows schools to request observations now, for example, now during the morning, and the telescopes in Hawaii, where it is still night, can make the observations almost on the spot, and if the object is visible, of course, and you can have the observations in less than 1 hour, the images in less than 1 hour, ready for you to analyze them. And a very important thing is that here. So our time as LCO educational partners was ending just now at the end of July. And I have a very good news to share. And it's that we have just been confirmed that PETeR has been reselected as an educational partner. So our users will be able to continue using these telescopes the next school year. So we have 1 more year of observation of access to the LCO telescopes. So this is just very, very recent news. I haven't announced this to the PETeR users, so you are the first ones to know that. Thanks. Okay. Fraser also mentioned other telescopes that PETeR users has access to, and they are about 50 centimeter telescopes that belongs to the Open University. The names are PETeR and COAST, and they are installed. They were installed a couple of years ago at the Teide Observatory, and they are available for student research projects mainly with COAST. That is, COAST is not going to be a bit larger. I think it was 36 centimeters, the telescope that we have until last week, and they were changing the tube for a new one. So now I think it's 50 centimeters, so it's a bit larger than the telescope that we have now for our observations. And the latest telescopes we have added to the project are the more or less 1 meter telescopes of the SARA network. So these telescopes are controlled remotely. So all the others that I have mentioned, the Liverpool Telescope, the LCO ones, and also PETeR and COAST, they work in queue mode. So you request observations and you wait for the images to come. But the SARA network works remotely. That means that you have to connect the day that you are assigned and make observations as if you were in the telescope room, in the telescope control room, but from home or from school. So we have this year we have been assigned 6 half nights that it's the last part of the night that they are okay for schools in Europe, more or less, because it's going to be out. They are on the telescope on the Kitt Peak Observatory in the US and also on Cerro Tololo in Chile. So during our morning, we can observe there during the night. So the observations have to be made from 8 a.m. to 1 a.m. depending on the time of the year, but it's about from 7, 8 in the morning until 1 p.m. or so in the afternoon. Okay, so it coincides very well with our classes, with our school times. So if you want to, if you are a PETeR user and want to do one of those sessions remotely, you have to write me an email saying, I will also announce this to all the PETeR users that we have been granted those observing nights, and we can have like 3-4 schools connected to each session, and we do remotely. I will be with you together doing the observations in that remote mode. And finally, this is not yet available, but it will be is another telescope that is being built at the moment is the new Robotic Telescope that will be a 4-meter optical telescope feeding several instruments and will be optimized for fast response observations, as also Fraser told us, and for periodic follow-up of variable and explosive objects. And so it would be the primary mirror will consist of 18 hexagonal segments of more or less 1 meter each, and it's also the IAC is also part of the collaboration that is building this telescope together with the Liverpool Johns Moore University and the other projects that you can see there. And a percentage of the observing time with this telescope will be available to the Spanish educational community through PETeR. So in a couple of years, not in a couple in the Canarian sense, that I think it's less than 10 years, we will have this telescope also available for us. Okay, so we have all these telescopes available, but what can we do with them? So what does PETeR offer to you to do with your students? So the project provides different approaches to experience real science. And one of them is the use of learning scenarios, which are designed for active learning. So each scenario introduces several concepts related to a topic of astronomy and provides one or more practical activities which make use of real astronomical images obtained with the PETeR telescopes. And the project also includes a student-friendly software, PETeRsoft, that I think we are not going to use tomorrow because we are going to learn how to use Salsa-J. But on those the practical activities on those scenarios, you also have following the teacher guide and the student guide, you can also learn how to use this piece of software, PETeRsoft, okay? And the software allows measuring sizes, distances, and brightness by doing aperture photometry. And I think it's quite similar to Salsa-J that we are going to start using this afternoon, but it's a bit more it's a bit more simpler. It's a bit simpler, sorry. So it's also very easy to use with primary school students. And the students can also complement the scientific process, requesting new observations with the telescopes using the predefined observations of selected objects, as we are going to see with the Liverpool Telescope. Or they can also develop research projects, either those proposed by us, by the project coordinators, or designed by the schools themselves. With this approach, students can experience the scientific method from deciding what to investigate, to prepare and request observations, and finally to analyze the data and draw their conclusions. So we provide orientation in the form of educational materials and technical and scientific advice during the whole process, and also the collaboration with other educational institutions, also with other schools, and with IAC researchers are very important for the design of some of the projects. For example, we are designing one research project about asteroids that I'm going to show you a bit of it tomorrow. And we are working with IAC researchers. One of them is Javier Licandro, who will give us a lecture on these types of objects, asteroids and comets, on Friday. And we are working with he and with other colleagues that are experts on this field to produce the materials that we are going to use. We are going to make available for all the schools. And what type of scientific projects can be done? So they don't have to be complex projects. So for example, I'm going to introduce you to a project that was done by a primary school, which consisted of studying what are the Messier objects. They are bright nebula and galaxies that are included in what is called the Messier catalog. And the project consisted on studying this type of object, this catalog, selecting the objects they wanted to observe, and that they could observe with the Liverpool Telescope during the weeks in which they were developing the project, then requesting the images in 3 different filters, analyzing them separately, and then finally combining the images to produce a real color image, as I showed you yesterday. So this project was made by the group of 6th graders, so it's 11, 12 years old students. And I have a video here that they prepare on the project. So I wanted to show the video to you just as an inspiration for those of you who are primary teachers, to see that this is possible also with your students. Can you hear the sound?
Yes, we can.
We can also do some video conferences with the school to introduce the project. Okay, so my connection is not very good. Okay, so as you can see, you can also do projects with primary schools. We also have with us Alicia. She also did a project, a complete school year, related. She with other teachers in her school. They did a complete school year project of astronomy with interdisciplinary. With an interdisciplinary view, and they were also obtaining images with the Liverpool Telescope and analyzing them. So it's also a thing that you can do with primary school students. And you can also do more complex things, more complex projects, as for example, this one that was a project that was born as a collaboration with an amateur association, the Centro de Investigación y Divulgación Astronómica del Mediterráneo, CIDAM, and it was developed by the High School La Devesa de Elche with the guidance of that amateur association and myself. And the project consisted of selecting an exoplanet candidate and to observe one of its transits with the Liverpool Telescope. So they planned the observations, and we obtained the images of the star during the transit, and they do differential photometry to the images of the parent star, and they represented and characterized the corresponding light curve, that is the variation of the brightness of the star during the time of the transit. And using internet tools that are freely available, they also analyze that light curve and obtain the data. They characterize the star and the exoplanet. And the project was This project was presented in 2014 to the international competition Science on Stage, and they won the first prize in the category Adopt a Star, aimed at non-university or pre-university students. And they were the first among more than 400 different projects that were presented to the competition in that category. They also appear on the newspapers, and it was something also very, very important for the students. And one last example is the project developed by a math teacher who attended our first astronomy adventure in the Canary Islands in 2015. And his name is Carlos Morales, together with his 13 years old students. They created a project, and also with our help, that consisted of trying to discover new variable stars. So they combined some archive data with new observations made with the Las Cumbres Telescope, Las Cumbres Observatory telescopes, and with a night of observation with an amateur telescope that belongs to an amateur association in Gran Canaria, that is another of the Canary Islands. And what they did is to analyze all those observations, all those images. They measure the brightness of all the stars in the field that they selected, and search for variations in brightness. So this year we are not going to do this project on the course. We did it last year, but if you want to do this project also, just be in touch with me and I will share all the materials with you, because I haven't had time to upload everything to the PETeR website yet. So what they did is then with mathematics, they did this project in the math subject, and they analyzed so they also did what we call differential photometry, that is to compare the brightness of the star with a standard star that we know that its brightness is not changing along the time. And then they analyze the light curve, the variation of the brightness of the objects with time, and they found two new variable stars that were not discovered until that moment. So they sent their results to the APSO, the astronomical, the APSO is the, what's the name? The APSO is the astronomy, I don't remember. It's the association that maintains a catalog of all the variable objects discovered, and they were this association told them that those stars were new, and they gave them certificates for being the discoverers of these two stars. Thanks a lot, Fraser. Is American, I think it's American, yeah, thanks, American Association of Variable Star Observers. Thanks a lot. So these students were the youngest in the world that have made a discovery of this type inside formal schooling. So we prepare a press release about the discoveries. They were on the newspapers, on radios, also on the regional TV. And this is just one example of the impact that this kind of projects can have on the students' perception and motivation with STEM. And all these three projects that I have mentioned were pilot projects, but then they have been carried out by many other high schools and primary schools since then. So the third target group that we wanted to reach, that is society, with these types of results, we can disseminate the project results to the society using our websites, the IAC social media, press releases, outreach articles that we have also prepared. So the idea is to show that science and technology can be accessible, is a fun thing, and that being a singer or an actor is not the only way to appear in the news, that there are also many interesting things happening, and this is just one way to try to reach also the society. And one of our very important objectives is to do what we are doing this week, to engage teachers, to train teachers, and we are running different training programs for local teachers through collaborations with the education department of the Canadian government. And since 2015, we organized this international summer course together with Núcleo, with the Folks Telescope project and the National Muchachos Observatory, and since the last 3 years also with the CESAR project. So at the moment we have reached more than 800 teachers, and we are really happy that some of you also repeat several editions, and not only to this international course, but also to our other specialized course for Spanish or Canadian teachers. And the important part, where you can find everything that I have presented. So the project is web-based, and we are continuously updating the website. So we now have a new website since this year. We have a new update, and on which I'm still working to upload some of the materials. And I'm going to invite you to visit it with me. And we will see where all of the things that I have mentioned, where you can find all the things that I have mentioned. So I'm going to stop. I don't need to, because I have it here. Okay, so one of the bad things is that the website is only in Spanish at the moment. One of the things I wanted to do is to also have it have an English version, but at the moment it's still only in Spanish. So this is the main web page, and you can find here also the latest news about the project. And one new thing is that we have a video gallery. So in this gallery, let me click on see all the videos. On this video gallery, you will find some, for example, some of the talks of this course are going to be available also through this video gallery. Also tutorials on how to do observations and how to use the tools that we are presenting on the website. You can also find some outreach videos, the ones that I commented the first day about the different areas of research at the IAC. And you can also find videos about the telescopes that we have in the observatories of the Canary Islands, and those that we have on PETeR. And you can also select the type of video, I don't know what's happening here, from these categories here. Okay, so you can also select which category you are interested in and just filter with that. Okay, so the first thing you need to do if you are a Spanish school, and if you want to participate on PETeR and you are not a PETeR user, so is to go here to participa, that is participates, and to register your school. So here you will find a form that you will need to fill in your data, and then you have to accept the terms and conditions for using the telescope. That is basically that you are going to use the telescopes for educational or outreach purposes, and if you want to publish any of the results and of the images obtained with those telescopes, you need to credit the telescopes, credit the IAC, the project, and also we request you to let us know that you are going to publish anything, because maybe we can help you and give also some diffusion of the results you have obtained. And it's also very important for the project to track all the results that have been obtained, just to continue doing this, because more results are going to say that many schools are using the telescope for doing real science. Okay, so this is not an automatic register. So once you complete this, I will receive an email, and it can take me a while because I have to check that you are who you say you are, and to give you access to the different observing platforms. So it's not something that is just you register and you have access to the telescopes. Okay, it's something that requires us to have a look to your data. And then once you are, even if you are not a Spanish center, a Spanish school, or a Spanish outreach center, you can also access the observations through collaborations with Spanish schools. And for that, I have prepared a form that you can complete. I'm going to show you. It's not finished yet, so I've been working on that yesterday. So, but I will show you how it's going to look like. So it's not only for schools in other countries, but also for Spanish schools that want to collaborate with other schools inside Spain or outside Spain. So here you will find, you will need to include your personal data. You are going to be the contact person for your school. So we are asking you for your personal data, and also some information about the school, the level of the students that you are going to work with in that collaboration, and also about the type of collaboration that you want to do with other schools. The language, it's very important if you want to interact with the other schools in English or Spanish mainly, and also the type of projects in which you are interested to do with your students and other students. And here you can also say, if I have put here the ones that we already have developed, but if you want to propose any other project, you can also do it here. And also we are asking you, when are you planning to do the project with your students, just to have the idea of if you want to collaborate during the first, second, or the third semester with other schools. So I will put the link to this form in the virtual campus on Grasp. So if you are interested to be part of the project, collaborating with other schools, you can also access that form. Even if you are not a PETeR user, you can find a lot of those learning scenarios or activities here. So they are, most of them are only in Spanish, But here in Discover, you have activities, and you have several activities on different topics on the planets in the solar system. You have Unit 1, 4, and 5. From Unit 1 to Unit 5, the level of the level of complex is always a bit more, and also in the activities you find here, we are introducing different tools of the software of the PETeR soft program in each, so from the basic ones to the more advanced ones. So what you can find in these activities, in these learning scenarios. So you find first an introduction. For example, this learning scenario is in Spanish and also in English. Okay, so let's go to the English version. And you can find an introduction that you can use with your students, or you can use as a guide for you. It's what I recommend, that you have this guide and you introduce the activity to the students, as I'm going to show you tomorrow, in a inquiry-based activity. Okay, so this is my recommendation, that this is just for you to have a guide about the topic that we are going to introduce to the students. You have some basic concepts about the planets on the solar system, and what you find here in blue, inside blue, those blue, I don't know how you call this, is a mathematical topic that you need to introduce, because we are going to use that concept on the activity. And then, as you can see, you have all the information. For example, in those activities, we name inner planets to those. So in this activity, the classification of the planets are related to the Earth position, okay, the Earth orbit. So we call inner planets to those that are closer to the Sun than the Earth orbit, and outer planets to those planets that are farther away from the Sun than the Earth orbit. Okay, because in the internet and in books you can find different ways of classification the planets. So this is the one we are using here, because the activities that we propose are based on our observations from the Earth. So this is the important thing, that the research that we are going to do in those activities is based on our own observations from the Earth. So this is the introduction, and then you find also the activities. And this scenario has two different activities, one about Venus that we are going to do tomorrow, and one about Mars that, if we have time, we will also introduce a bit of this tomorrow. So this is an example. You have here the guide of the activity, also in English. So I also recommend that you use this, but only for you, not with your students. You are going to guide them through the research project using the information that we provide here. And you can see step by step what you have to do with the images that we also provide on the website, and how to use. We also introduce how to use the different tools of the PETeR soft program, how to do zooming, how to measure the distances, and so on. We will do this tomorrow together. Here you also have the images of the, in this case of Venus that we are going to use. And we also provide a spreadsheet, but this one is only for its Excel spreadsheet. I also wanted to upload one in OpenOffice for you to download and use it. And tomorrow I will show you how to prepare also the a spreadsheet in Google Docs, so you can collaborate. All the students can collaborate on producing the final spreadsheet and the final results. Okay, so this is the activities that are open for everybody. So you don't have to be a PETeR user to use this with your students, with your the people with you are doing outreach activities. And then maybe the most important or the most interesting thing is to also do your own observations. So how to do that? So once you have your passwords for accessing the observing portals of the different telescopes, so after I send you the welcome email to the project, you can go here to observa in Spanish, and you have here the different telescopes that we have available in the project. And now there are only 2 that are on the website, but I also presented you that we also have access to the Ghost telescope from the Open University and to the SARA telescopes in remote mode. So they are not here because you need to request using them. But I'm going to put at least them here in the following weeks. And if you press any, for example, the Liverpool Telescope, you have all the information about the telescope and also the observing modes that are available with this telescope. You can also do a spectroscopy with this telescope, but you need to need to prepare an observing proposal explaining why, for what project you want to do a spectroscopy, and I will help you with the technical part and also obtaining the observations. And then here, not here, so you also have here a real time. This is a webcam next to the Liverpool Telescope, so you can see the telescope in real time. And here it's observe the universe with PETeR, and here you have 2 options. So at the moment we have from the website you can access 2 of the observing portals. The one on the one for the Liverpool Telescope and the one for Las Cumbres Observatory. So I'm going to let's see what time is it. Okay, so I think I have time to show you at least one of them. So I'm going to so here we have observations with the Liverpool telescopes that are pre-designed. We are going to see what that does mean, and also open observations with the Las Cumbres Observatory. Let's go to the first one. The observing portal for using the Liverpool telescope, it's included in the portal of the National Schools Observatory. So if you go here to Quiero observar, I want to observe, and you click on the robot or click here, you will be redirected to the National Schools Observatory portal, observing portal, in which I agree, in which you need to put here your username and password once I send it to you. So here you need to put your username. This is mine. And you will enter the part of the National Schools Observatory portal that is in Spanish. Okay, so I'm entering mine. And you can see here at the top that one of the images I have requested, it's telling me that it has been already taken by the telescope. And I'm going to open this for later. And you can find here the type of objects that you can observe with the Liverpool Telescope. So we have also, with the help of the director of the National Schools Observatory, we have also updated the options that Spanish schools have to do the observations with this observing portal. And now we have a lot more options to observe the universe with the Liverpool Telescope. For example, if I choose galaxies, you have different options from observing one galaxy to obtain the image of to obtain 3 images of the same galaxy in 3 different filters. So I'm going to click here just for you to know how is. So you have here a list of galaxies, and here you have also the classification, the type of galaxy, if we know which is its type. And here on the right, you have a color code telling you if the moment for observing that galaxy is good or not. So you have here from August the 1st of August to the end of the month, and light blue or almost white is that the conditions are perfect for observing that object. That means that the galaxy is up on the sky during the night from the Canary Islands. So it's the perfect moment for observing it during the next days or the next weeks. And black means that the galaxy is not visible from the Canary Islands, so the Liverpool Telescope cannot observe it during that period of time, during the night. Maybe it's below the horizon for when it's night in the Canary Islands. So if you select one of those, do you have any preference? Also, if you click on information here, you will obtain more information about this galaxy. But this is just in English, so we have to work with the translations. Some of the translations are okay, but some of other are missing or are not good. So one of the things I have to do from here to September is just checking all the translations to try to have everything correctly in Spanish. Okay, so Karen said the fireworks galaxy, so let's go for this one. And if we click on the name of the galaxy, now we have everything we need to obtain 3 images of this galaxy in 3 different filters. So this is why we call this type of observations pre-designed, because we select for you which is the best exposure time for observing this galaxy and obtaining information not only of the center of the galaxy, but also of in this case, of the rest of the galaxy, the spiral arms. So we are telling you that you need at least 90 seconds to observe this galaxy and to obtain information of most of the galaxy. We also select for you the filters, the red filter, the green filter, and the blue filter. So you can obtain the 3 images and combine, so assign each image the corresponding color and then combine them with the software to obtain a real color image. So you don't have to just, you need to select the object you want to analyze, you want to investigate, and more or less is ready for you to just clicking here in send observations, enviar observaciones, and then you send your request to the telescope. And this request is going to go to the list of observation requests of the Liverpool Telescope, and in a couple of days, in a week, or sometimes in 2 weeks, you will have your images ready to be downloaded. Okay, as I have mine here. So once your observations are done by the telescope, you are not receiving an email. You have to enter the website and see if the images are already for you to download. And here you have a lot of information of the related to the observation, not only the images, but also information about the how was the night in which the observations were taken, how were the weather conditions, and so a lot very important information that you need to evaluate if the images are good, if you see anything strange, why could be what could be the reason for that. For example, if there were clouds in a part of the observation. Okay, so here, so observation details, you have the filter. Okay, so another way to reach this, a very important thing here is that as we are inside the National Schools Observatory portal, if you want to navigate to another part of the Spanish portal, you need to go back. Okay, so for example, if I'm here and if I want to see all the observations that I have requested, I cannot click on the main menu, because if I do so, I go to the English part and I don't have access to my data. So I have to navigate back or to click here on home. Let me click here. No. This is the problem. I clicked twice and I was out. Okay, so. Okay, and once more. Clicking home, this is one of the things I have to check, because clicking home, I should be landing here. So here, okay, so we can, oh, another thing I wanted to show you, that we have more options, and I forgot to show you what are those advanced options. So here in, I think it's observe a galaxy. No, where is it? Because this is an advanced option. And where is it? Okay, let me try another one. It should be here. Let me check, for example, planets. No, planets is not a good one, because we should have a big list of objects in advanced options. Okay, so here in advanced options, you can find many other new options that were not available before. For example, observe a nebula or a galaxy advance. And if I click here and here in OK. Okay, so now you can select, you will find many other options that allows you to have a more real investigation or research on what are the best moment to observe the object, what is the best filter, and also the best exposure time for your images. For example, if I said that I want to observe the object tomorrow, and the question here is, I want the image tomorrow or in the next week or in the next month, next 3 months, and so on. So I am going to say next week. And then I have a large list of objects that I can select. So this is almost everything that the Liverpool Telescope can observe during the next week. And if you select any of them, for example, any of them. Okay, so now you can select the exposure time between these options that are more or less good for the type of object that we have selected. And also you can select the filter you want to use. You have what we call broadband filters that gives you a lot of different frequencies in one color range. And you also have available the what we call a very short filter that only allows you, or only allows the light coming from one color to reach the detector. That is, it corresponds to to the emission of hydrogen in one of the most the brightest spectral lines of hydrogen, that is called the H-alpha line. So we also have this very narrow filter that allows you to observe, for example, this is very interesting for nebula or for galaxies, to observe the emission of the hot gas. Okay. So then you select the time, select the filter, and if I say OK, you can also say the telescope in which conditions are you okay of obtaining those images. If it should be when the moon is not up on the sky, and also you can say something about the weather or the what we call the photometric conditions. That is, if it's okay for you to have not perfect conditions, not perfect stable atmosphere, but you can have a bit of turbulence, and if it's okay for you or not, or just you need very, very good conditions of the atmosphere to obtain your images. Once you are happy with your selection, you click on OK, and you are going to request your images. Okay, so these are the new options that you have on the Liverpool Telescope observing portal. And let me check what time is it, because today I have to leave quickly at 12:30. So just one more thing related to the observations is all the information that you find when your images have been taken. And this is not a good thing that you have to navigate. Let me check now, just in case. that you have to navigate back is one of the things we wanted to solve with Andy Newsom, that is the director of the National Schools Observatory, but we haven't had time yet to also have this main menu in Spanish for you to navigate. Okay, so if you go to my observations, mis observaciones, you have here the list of the latest observations you have requested, and that they have all the ones you have requested in the last I think it's the last year or so, and you can download directly download them from here. And once you click there, as I told you before, you can download the images clicking here, but you also have a lot of complementary information. For example, the observing conditions that night. So if you click here, you will see the moon phase during that night. Here you have an image of the complete sky obtained at the same time of, or more or less at the same time as when your image was taken. This is also the field of view, a greater field of view than the field of view of the Liverpool Telescope. This is with another with a side telescope. Here you can find so this image is the same as this one, but this is a reproduction of the sky, and this pointing here is telling you to which part of the sky which part of the sky you were observing. So you took the image of this part of the sky, and here you also have a video of the movement of the Liverpool Telescope during that night. So this is a reproduction, and this is the real image of the telescope. You can see that it was closed part of it started to observe. No, it was closed part of the night, maybe because the weather was not good at some point. Maybe it was a bit windy, and when the wind is over a certain limit, the dome needs to be closed just to protect the telescope. You can see the Milky Way here, even in this black and white color and the small color. You can see what the impressive the Milky Way could be in La Palma's sky. Now here is the moon, so we cannot see the Milky Way anymore once the moon appears. And also you can have information about the meteorological conditions here. So I am going to stop here. Just you have here information of the meteorological conditions, the direction of the wind during the observation, and so on. So you have the images and a lot of information that complement your observations, and you can also use it for your research.